How are you doing today? You're interested in soldering. So am I. My name is Jack. Plenty of broken electronics can be found around the average house. I have a broken stove. Today I'm going to show you how to fix it. The heating elements inside here have stopped working. After some troubleshooting, I found that the problem is in the control panel right here. After removing the control board and examining it, I find that the leg on the relay has been under-engineered, causing it to burn up. This is the part we're going to be fixing. This is caused by under-engineering. It's planned obsolescence of the board so that the customer has to buy a new one every so often. This stove did last 5 years before needing repair. That's not too bad. The most basic of repairs can be accomplished with the following items. A soldering iron. A 25-watt soldering iron is a good temperature for doing most things. 25 watts runs about 650 degrees Fahrenheit. Solder wire, it's often called solder, is 60% tin and 40% lead, referred to as 60-40 solder. Solder comes in many formulas: 6733, silver, and even gold. Solder with a rosin core is the most useful. A desoldering pump, used to remove old solder. A damp sponge or a damp paper towel. Here I'm using a damp rag. It'll be used to clean the tip of the soldering iron. Sandpaper, used for cleaning board surfaces. Bits of scrap wire, used during the repair. A rigid tool used to hold items in place so you don't burn your fingers. I use a small screwdriver. It works great. These are some other tools I find useful for repairing electronics. Here's the problem area I found. It has overheated and burned from the oven coils using so much current. All we need to do is add some more surface area for the current to flow. I'm going to do that by adding wires to the leg of the relay and branching them out. To make things go along more smoothly, I'm going to clean off the carbon from the burned area with some sandpaper. There, that's much better looking. By now, the soldering iron should be hot enough to work with. A clean tip is crucial for any soldering job. This is where we use our damp sponge. Quickly swipe the soldering iron across it to shock off any dirt that's on there. Then we use some of our solder to wet the tip. Just gently touch it and the solder will melt onto it. The solder just paints on there. Leaving a thin coating of solder on the iron's tip helps protect it from corrosion. And that's it. Our soldering iron is ready to use. I'll use the soldering iron and the desoldering pump to make room for the new wire pieces. That looks good. Now it's time to find some scrap wire to do the repair. A common novice mistake is to push too hard on the soldering iron. You don't need to use any more weight than the weight of gravity pulling down on the iron. When the iron is hot enough, just the slightest touch will melt the solder, similar to candle wax. The thicker the solder is, the longer it will take to heat up and melt. If the iron has been touching the solder for 15 to 20 seconds and you still don't see any melting, this could be due to two different things. The iron you're using may not be able to get hot enough to melt the solder you're working on. You'll have to find a higher wattage iron. If you know your iron is hot enough, then the problem is usually a heat insulating effect caused by a thin layer of corrosion on the solder. Even though the solder may look clean, it takes a surprisingly small amount of dirt or patina-like corrosion to keep the iron's heat from reaching the work area. To fix this, all you have to do is lightly scuff the work area with some sandpaper. Also, wetting the tip of the soldering iron will help transfer the heat to your work area. This would also be the only appropriate time to apply more than a light touch with the soldering iron. A gentle scratching with the iron may be enough to get through the light corrosion and heat the solder to the melting point. Pre-tinning the wire makes it easier to solder onto the board. And that is how I'll be applying the wires. The flux chemically cleans the wire so the solder will stick to it better. I tack the wires down so they don't move. All done. Looks good. There's no cracks or gaps in the solder. Now, we just have to test it. The controller board is installed back in the oven. Let's turn it on and see what happens. This is jokingly referred to as a smoke test, because if I did something wrong, smoke would come from the controller board. So we just push these buttons here, and it should get hot enough. Yep, there's the oven coils heating up. It works. You just saved yourself $200 by not having to buy a new controller board. Thanks for stopping by. And until next time, this is Homeless Veteran Electronic Repair. What? Just stand here? Am I done yet? Can I have lunch now?